So this last section, this is the last one that you will do. Next class we'll have a review, and then the following class will be test. So this last one is about inverses, and we're going to learn how to graph inverses. And the only thing that I have to say about inverses is that you switch your x and y. That's all you have to do. So let's look at, here's a picture. It's going to make a rocket ship, and it's going to be pretty cool. But for table 1, I want to put all of the ordered pairs for the stuff that's on the left side of that line. So go ahead and fill out your ordered pairs, all of your x values on the left, all of your y values on the right, and that's going to go in your table 1. Okay, what I want you to do now that you have those ordered pairs, I want you to take the x and the y column and I want you to switch it. So the top one would be 1, -6, -2, -4. So I want you to switch the two columns, and then I want you to plot those ordered pairs. So switch the columns and then graph it. Graph those ordered pairs. So what relationship between the points in table 1 and table 2? We would say that they are inverses of one another. So they are inverses. So to find the inverse, we simply switch the x and y values. Just switch them. The inverse is a reflection of a graph over the line. So here's my line right here. Think back to Algebra 1. What line is that? Y equals what? X. Y equals X. All right, there we go. Y equals X. So by switching X and Y, that means I'm reflecting the diagonal line Y equals X. So for number 6, it says if the point 2, -3 lies on the line f of x, or lies on the function f of x, then what point would lie on the graph of its inverse? So if I have 2, -3 and I'm finding the inverse, what would the inverse point be? -3, 2. Good. So all I did was I switched x and y. Easy as that. The same thing applies to domain and range. Okay, so we're going to go back to 1.5 and think about that. State the domain and range in interval notation. So I'm looking at, if you want to take your two colors, you can, or you don't have to. Domain is from left to right. Interval notation, what would that look like? Where does it start? -9. Does it ever stop? No, it keeps going to what? 8. Would I put brackets or parentheses? Brackets. Then for range, I'm going to put the lowest point and the highest point. So what would the range be from where to where? -2 to 9. Brackets or parentheses? Brackets. Okay, what I want you to do now is I want you to find those ordered pairs and I want you to graph the inverse. I want you to graph the inverse. So find the ordered pairs. So if they were like at 1, 2, then switch them to 1. So I want you to graph the inverse. You might want to try it in a different color. It might help. Sometimes it helps for me to draw the line y equals x. I just made like a dashed line. And think about, okay, if this point is here, and I draw a straight line across, it's going to have like equal distance to that line. It's just like flipping it. So I think we learned that in geometry, like a reflection. It's doing the same thing. It's taking this whole function and it's just flipping it over that line. But if you're more of an algebra kind of person, which I feel like we are, or I am at least, I take this ordered pair here, and I see that that ordered pair is at -9, 5. And so whenever I'm finding the inverse, I'm going to switch it, which would be 5, -9. So I go right 5, down 9. This is at 5, -9, and I plot that point. So I just find each ordered pair, switch it, plot it. And I did that for all of them. So it creates this little picture. I guess you could say it's an octopus. I don't really know. Or a kite, kind of. A weird kite. I don't know. I don't think it has to be anything. And I want to find the domain and range of that. So I'm going to use different colors now. And I'm going to go from left to right. So for domain, it starts at this X value and it goes to this X value. So what is my domain? Like, where does it start? At -2 and it goes to 9. And what do you notice about that compared to the original one? It's the range, yeah. So all I did was switch it. That is always true. You don't have to draw a picture to figure that out. It's going to be true every single time. So domain and range of the function is the inverse is switched on the inverse. So the range becomes the domain becomes the range whenever you have an inverse. So if we were to predict the range, you can even check it if you want. If I were to predict the range, I would say you think that it is what? -9 to 8. Awesome. Then you can also check it if you don't believe me, but you should believe me. So domain and range switch on the inverse. So not only do the x's and y's switch, the domain and range also switch, which makes sense. So if the x's and y's are switching, then you're finding that domain and range, which is your x's. If it were the domain, it's the x's, now becomes the y's. So now becomes the range. The range were the y's. When you switch it, it now becomes the x's. So that also makes sense. When another question that you might see is this a function? And how do we tell if something is a function or not? The vertical line test. Sometimes, if you have something that is a function, which means that no x's repeat, if you find the inverse of it, how do I tell if that's a function? I need to make sure that the new x's don't repeat, which means that in the original set that the y's didn't repeat. So let me say that again. If I'm telling if something is a function or not, like the original. If the original is a function, then I look to see that no x's repeat. If a question states, is the inverse a function? So question says, is inverse a function? What am I looking for in the original set of data to not repeat? I have to say that no y's repeat. So you could have an instance where something is not a function because the x's repeat, but when you find the inverse, now it's a function. Or you could have vice versa. So it's a function, but when you take the inverse, it's not a function. So it just depends on whether you're looking for the x's or the y's. For this, what's the domain of the original? -8, 4, brackets or parentheses? Brackets. What'd you get for the range? -4, 7. So then to find the inverse, I went ahead and graphed it for you. If you can't connect the dots, maybe like on a test or quiz, that's okay, because it was kind of confusing on how to graph or how to connect the dots. I think that's right. It looks kind of right. But what would the inverse domain and range be? So the new domain is -4, 7. The new range would be -8, 4. So all I did was switch. Okay, for number 13, I want you to actually find the inverse, so graph it. Then do domain and range of the original, domain and range of the inverse. So here we have a table. We don't know if it's necessarily like a function or not. But we have a table with ordered pairs. So if I want to find the inverse, what do I need to do? Need to switch them. So I'm going to take all the y values and make them x's. So y'all can help me fill out the table. So let's decide, is the original a function, yes or no? Do any x's repeat? They don't repeat, so I would say yes, it is a function. Now I'm looking at the inverse. Do any of the x's repeat on the inverse, or any of the y's on the original? No, so I would also say that yes, the inverse is a function. And so if the function doesn't, or if the function original is a function and the inverse is a function, that means it's a what type of function? One-to-one. That means no x's, no y's repeat. I should say function. How to do domain and range on like a table. It's different than doing interval notation. It's a little special. So all that you do when you have a table for domain is you make a fancy curly bracket like this. So everyone practice making your fancy curly bracket. And you list out all of the x values. If x values are repeated, then you only list them one time. In this case, they're not repeated. So I'm going to put -1. And you also list them from least to greatest. So -1, 0, 2, 4, 5. Range, I do the same thing. So fancy curly bracket. I list them from least to greatest. So it's going to go 3, 6, 8, 9, 10, close. Then for inverse, I switch them. So domain becomes 3, 6, 8, 9, 10. Range becomes -1, 0, 2, 4, 5. If we look at number 17, go ahead and fill out the table for the inverse. Is the original a function? Yes. Is the inverse a function? No, because of the 6's. Okay, I'm going to show you really quickly the domain -2, -1, 0, 1, 2, but the range is only 5, 6, and 9. So I only list them one time.